Okay, today is going to be a 1.5 hour class, ma, so that we finish what we have. Okay. Any questions on last week's homework?
Miss Priya, I didn't get to do last week's homework.
Oh, you're busy.
Yeah, we were traveling the entire week, so it was a little hard.
Oh, for you, was it spring break, ma?
Yeah, it was spring break for us.
Oh, I'm sorry. Okay, okay. So I hope you enjoyed your spring break.
Thank you.
Coming back to Sahana's mom is an action item for me, but I'll do it this weekend, Sahana. I'll be free. Okay. Tell your mom.
Yeah.
It's a note for Sahana. Okay. Okay. Now I wanted to go.
Yeah.
Yeah, ma. Yeah, Dhruv, go ahead.
I didn't get to like check my answers
Yes.
because I
Did
couldn't.
not post, right?
Yeah.
Ashrita asked me, I posted only today. Later in the evening, after my work, I scanned it and put it. I'm sorry for the delay, but I did put it. It's module 17, right, ma?
Yeah.
Yeah. I put it only now. Take your time and do it, okay? Uh, Coming to Algebra 1 review, right, guys? Shall I start putting it in the classroom during the break? It would help you, right? If we start working on the EOC review, it will be helpful, right? Let me go over it first and then I'll go to intercepts and stuff, okay? I don't know whether I went over it though. 1 second, guys. I want to go over it with you. First of all, I want to show you what I'm going to give you and then I want to give you that. Give me a minute.
I think you already posted a star review, EOC review.
Oh, I did. Good, good, good of me. Nice of me.
Hey, you
Let me.
posted it on the call with my mom.
Oh, that's good. Oh, yeah, yeah, I have posted. Oh,
I
okay.
didn't
Let's
get to
go.
do the homework because I just got the book yesterday. But I did some of the EOC review.
That's nice, ma. So was it easy, Sahana?
It was okay. It was like a little crazy because we just learned that some
Yeah,
of it.
still, some of the stuff you would not, I think most of the stuff you would have learned already is my honest thought, but I want to go over that with you. Just a minute, hold on. Okay, guys, see here. This is what I posted, okay? So I want to tell you certain things. See, module 17 answers I posted only at 1911. That means what? It's my time. So your time 611. It was a little late, I know, but I wanted to post before I met you. So I posted. You can review the answers later. Now, EOC for the end of course review of Algebra 1, right? Please start working on these. What are these? Let me come back to other EOC review. Okay, let me come back to other EOC review that has been posted here. We'll talk about it later, but before that, this one is quite important. Okay, what does it do? When you look at it, right? RC means root category. Okay. Root category. Algebra 1 is split into, see, this is root category 2, second set. Root category 2, first set. Each set, each root category has two PDFs, two tests in it. Am I making sense? Root category 1. Okay, let me show you. When you go to root category 1, right? Where is the root category 1? Root category 1. Do you see? Root category 1 will have two sets of tests. Root category 1, 1. Root category 1, 2. Root category 2, 1. Root category 2, 2. Root category 3, 1. Root category 3, 2. Where is it? 3, 1. And am I missing 3, 2? No, 3, 2. See, it will be there. Okay. Don't refer to the test key until you finish the test. Okay. Then you have 4, 1, 4, 2. Then you have 5, 2 and 5, 1. Do you see? So you have 5 root categories. Each has 30 questions. That means each is split into two sets, 15 questions. Each has 30 questions. So on an average, each root category has 30 questions. So 5 times 30 will be 150 questions. You see, so this covers all your root categories for Algebra 1 review. Whatever, there will be certain things that you won't remember. 100% whatever we covered in August, some of you may not remember. That's fine. This is for you to identify which are the topics you don't remember and come back and let's discuss that in the forthcoming classes. Any questions for me? Coming to the test key, right? So for every root category, there are two sets, right? So when you look at it, see, there is a test key for root category 1, 1, root category 1, 2. Do you see? 2, 1, 2, 2. You have the key. 3, 2, 3, 1 key is here. 4, 2, 4, 1 key is here. 5, 1, 5, 2. Where is the 5, 1, 5, 2? 5, 2 is here. 5, 1. Where is the 5, 1 test key? Yep. So you have the test keys correspondingly as well. Any questions on this? So how would I take it if I was at home? I don't want to refer to the test key, okay? Go to the original one, root category 1, 1. Let's consider this. This is like a test. Take it like a test. Then only you'll know where you stand, what you don't remember. Everything will get out. Okay? Solve these 15 questions, okay? Stop here. Go back to the test key. Okay, if you get something wrong, then come back. Let's discuss. See, these are just multiple choice questions. It's not even testing anything, okay? So this is how I would have done it. Any questions here? Like this, you have to go through all the 150 questions. Okay, this is the algebra 1 level, meaning for your end of course, this is a review. Whereas there's something else in your Google Classroom. Benchmark by benchmark, I've started posting some reviews. Guys, please make sure you do these reviews, because when you take your PSAT next year, this will be your base. You see, PSAT, how to score better in a PSAT exam. Only when you do these, you will be able to recollect. Just passing EOC exam is not at all important. You will all pass, I know. But how to get 100 in your EOC exam? So do these. If you don't remember a particular topic, message me or come back to class, ask, and we'll definitely review that topic. Now, what are these? These are just easy reviews. Okay, this one, this EOC full review where you have test keys and root categories is all easy reviews. Okay, easy means in the sense these are easy questions. Okay, based out of Texas end of course exam. Okay, the end of course exam is pretty relatively easy. Whereas when you come to these reviews, right? Review for Algebra 1 EOC, review for EOC Algebra, benchmark 9, benchmark 10. If you see these, right? These are challenging questions. Why are these challenging questions? Let's go ahead. See, each benchmark is going to have a lot of questions, okay? This is for those of you who are motivated, who don't get dejected by getting things wrong, okay? I don't want to pick and choose, hey, you do. No, nothing of that sort. If you are really having the grit and having the patience to work through this, I would definitely want you to work through. You got it? Because these are the challenging questions which will really challenge you. You get it? So I expect you to do this and submit it. Not now. Do you see? I have put it as due date 28th Feb. I can extend it if you want to. These meaning I'll post more. See, this is benchmark 9, 10. Where is 8, 7, 6, 5, 4, 3, 2 that we covered from August? I have not posted it. So I will be posting one by one now. Now that you have your EOC in April, right? Right now when we start, you can finish up all the benchmarks. So please, these are the challenging questions, and those of you who are really interested in doing and properly doing Algebra 1 and taking the PSAT next, for you guys only I'm posting it, taking my time, okay? So I prefer that you do, okay? And if you have any questions, particularly in these challenging ones, right, definitely come back and ask. I would be more than happy to help. Okay, any question. Okay, but it is your duty to come and ask. It's not like you just submit it, go, don't check the answer. It's you who should check the answer. Then if you have a problem in your answer, it's you who should come and ask. If you want, come and ask. You got it? But I'll be posting the rest of these. This one I have already posted everything here so that I am not a blocker. Okay, the easy one I've already posted. The challenging one, yes, I have left. What I have left, I have all 8, 7, 6, 5, 4, 3, 2, 1 benchmarks. I have not posted. I will post it. You can even take it slowly and do it even after your EOC exam, but definitely practice this set of Algebra 1 questions. Okay. It will be very useful for your PSAT as well. Getting to know, being on your toes in the Algebra 1 concepts benchmark by benchmark is quite required. Okay. Even if there are certain things where you're getting confused, bring it back to class and we can discuss in any of the classes till May. Okay. Any questions here? Yeah, I gave a long lecture, right? So now it's your turn. Any questions?
No.
Okay. Okay, now let's go to our, what did we leave? We did till 8:31, 8:32. Okay. I know we did not find the x-intercepts properly by factorizing, right? What are they doing in school, Marshita?
Oh, we learned the quadratic formula.
Oh, we learned the quadratic formula, okay. But did you factorize trinomials and all?
Yes.
Factorize using GCF?
Yes.
Okay, cool.
We're done with normal quadratics. Next week we start transformations of quadratics.
Oh, okay. 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 We did, okay. I want you to go ahead and express an intercept form. How do we find the intercept form? Let's see. Give me a minute. I want to go over slowly one by one, factorizing quadratics first. Let's see. Mm, okay, guys, how about this? See, how about this? Suppose if I have things like this. First, let me consider factoring by grouping. Yeah, let's consider this. If you're given a polynomial like this, right? You are given a polynomial like this, x square minus 16. This is basically a binomial, right? But this is a square term. This is a square term. What is meant by a square term? Some number square is x square. Some number square is 16. So when you have square minus a square, right? Do you remember the formula? A square minus b square equal to a plus b times a minus b. So you can, so consider a as x, b as 4. This is a square minus b square. So I can split it out as x plus 4, x minus 4. Any questions here? Now, if I give you 4x square minus 81, see here, this is sum of terms. I have to express it as product of factors. How do I do it? Remember the formula again, because this is a square term, this is a square term. So what it will, meaning if I write it into a product of factors, what it will be? Any thoughts? Any thoughts, anybody?
2x plus 9 multiplied by 2x minus 9.
Good job. How did you find it? This is a square term. So what is a actually? 2x. The square root of this. What is b? B is 9. So 2x plus 9 and 2x minus 9. Any questions, guys? Can I go ahead? How about 64 minus 16x squared? Who wants to try? If I give you this binomial, right, how will you write it out as product of factors? Why do you want to write it out as product of factors? I'm always talking about product of factors, right? This means that is the intercept form that we discussed last week. Go ahead. How do you, first of all, let's write out the product of factors. How do you do it? What square is it? What square is it? I want somebody else to answer. Dhruv or Avni, you want to answer this one? Or Akshada?
8 minus 4x.
Yeah. 8 minus 4x, 8 plus 4x. Make sense, guys? Does it make sense?
Yeah.
Okay. So this is how you put it out as product of factors. Now, if this is my function, right, it's a quadratic function. It's going to be, see, if the leading coefficient is negative, it is a downward facing parabola in the graph. Leading coefficient means what? The highest power of x has a coefficient, the number accompanying the highest power of x. That's negative, right? So it's a downward facing parabola. Okay. Okay, let's go ahead. When you want to graph, okay, graphing it, we'll see. Okay, I'll come there. Now, suppose if you have a trinomial like this, what is this, guys? When you look at the trinomial itself, you should know which is best for me to which is the best method to factorize?
Um,
This is square, this is a square. That itself, this is not a square in between. So that itself tells you. Remember this? Yes, Dhruv, you wanted to say something? Go ahead.
X plus 2 squared.
Yep. So you have to remember these two. Okay. You have to remember these two. Okay. When the first and last term are square, see whether it will obey this formula. See, a square. I will write it a as x, b as 2. 2ab means what? 2 times 2 times x. 4x is here. See, plus 2ab. So which formula will it obey? X plus 2 the whole square. Am I making sense? Okay, so see, given a polynomial, given a quadratic equation, finding how to factorize it, finding how to write it in intercept form is a special skill. Okay, we should be able to find out whatever it be given. Now let's try this one. 4x squared plus 6. How about this, guys? What is this? Anybody can say. Don't worry if you don't get it. You'll get it as we move on. What do you think? This is a square term. This is a square term. So you'll have to check up something.
2x plus 4 squared.
Yep. 2x plus 4 the whole square. Do you see it? There's a plus in here. So this has to be a plus. Any questions? See, 2x, what a square is this? 4 square is this. Annam, are you following? 2 times 2x.
Yeah, I understand.
Yeah. So now let's see. There are two things that we have discussed. So let's find out this one. How about this? You are going to send this to me in chat, please. Okay. You're going to send it to me in chat. Factorize it and send it to me in chat. Factorize means you're going to express it in intercept form, or you're going to express it as product of factors. 25x square plus 10x plus 1. Go ahead, guys. Krishup, did you miss the plus in between?
Yeah, I missed it.
Okay. Pratika, okay. I have a problem with yours. Pratika, okay. Dhruv, what is that? 5 is outside. What is that, Dhruv? Subhi Ashita, okay. Akshada, where is your answer, ma? Sahana, correct, na? Sahana, correct. Advait, power 5, power 2, right?
Yeah, I mistyped.
Uh-huh. That's incorrect, Akshada. Mm.
Miss Priya.
Annam, where is your answer? Yeah. See, guys, 25x square plus 10x plus 1. As soon as I see this is a square number, this is a square number. What square it is? This is 5x square, this is 1 square. So let me do 2 times these two numbers becomes 10x that is present in here. So that makes it all. So this is 2ab, this is b square, this is a square, and there is a plus in between. So 5x plus 1 the whole square. Any questions? Akshada, did you get it?
Yeah.
Okay. Now suppose let's go with this. How about this? This is the last one, guys, in this type. Okay. I would really like you to be able to factorize anything given. Okay, this forms your base for algebra 2. Go ahead. How will you factorize this? Check, meaning look at the problem first, okay? Are there squares am I finding? Yes, the first and last numbers are square, but it's a little bit interchanged. X square is at the last. So think about it and properly send the answer. If you want, you write down what is A, B. Yes, Dhruv, that's right. Krishiv, Krishiv, I really want you to write it correctly, Krishiv.
Yeah, I missed again.
Yeah. Ashrita correct, Subi correct. Subi, that's incorrect, ma. Why did you Annam? Why 9x minus 9?
That was
That is incorrect, Subi. Advik correct, Pratika. Why 9 minus x, Pratika? Pratika. Why 9 minus x?
Miss Priya.
Uh-huh.
Can I go get some water?
Go ahead. Yeah. Go ahead.
Can I go get some water?
Yeah, please. See, this can be, this can be, A can be, you can have it, anything as A. This is A or this is A. It can be x minus 9 the whole square or 9. Both are one and the same, basically. Because it's squared, right? It can be any of these. Okay, good guys. I think you all have gotten this nicely. So let's try a different perfect trinomial, perfect trinomials, perfect square trinomials we are done. Difference of squares. Okay, how about this? This is a good one. How about this one? Okay, this one we'll do and then we'll move on. Okay, 4a square minus 81b square. How do you express it as product of factors? Product of factors. Akshada, that does not seem right, right, Akshada? Guys, this is of the format is Annam. What is that Annam? Yeah, Pratika, that's right. So this is of the format a square minus b square. So what is a, what is b? A is 2a, b is 9b. A square minus b square means what is the formula? I told you, right? You have to get up from sleep and say a plus b, a minus b. 2a plus 9b, 2a minus 9b. Any questions? Annam, do you see the problem, Annam?
Yeah.
Advik, are you
Wait,
able to?
Priyanti, I just got 2a minus 9b squared. Do I have to get 2a plus 9b?
One is 2a plus 9b, the other one is 2a minus 9b.
Oh, I just put a square next to it.
It can't be right. It has to
Yeah.
be plus 1 minus.
Okay, thank you.
Advik, how about you? Did you get it, Advik?
Yeah.
Okay, how about Sahana?
I get it.
Okay, so as soon as you see it, you should be able to detect. This is called difference of squares. Squares, difference of squares. Okay, now the next format would be this one. Perfect. Square trinomials we are done. Grouping. Okay, how about this? If you are given a polynomial like this, okay, now I want you to understand how to express it as product of factors. When you look at this, right, there is no square terms or anything. It's just weird. These two have excess common. So I'll take excess common. That is a GCF. GCF means greatest common factor between the two terms is x. And then inside I have x plus 2. Again, between these two, I have y as common. So plus y, I take it out as common, x plus 2. Now, see, this is a product, this is a product. But what is common between the two? I take x plus 2 outside. What remains is x plus 5. Any questions in this? Any questions, anybody?
No,
You'll have to work it out. Annam and Advait.
I understand.
Okay, so
I
taking GCF and writing out as a product of factors is important too. How about this? As soon as you see this, you don't see square terms, but there are common factors. There are 4, and you can take out common. Then you can take out the common of that. Ashrita. Again, you can simplify that, right, Ashrita? The second term is not simplified. Second term is not simplified, right?
Can I resend it?
Yeah, please.
Okay.
Done?
Priya ma'am, I'm having confusion, a little bit of confusion. Can you
Yeah,
explain
correct.
this?
So B, the second term can be simplified, right? So B. Second term is again a difference of squares. Krishiv, that's not right. Guys, okay, I'm going to do this on the board, okay? X square A plus x square B minus 16A minus 16B. Here, there is no square term. I don't see anything. But then, there's a lot of common. If I take x square as common, I have A plus B in this. And then, I have minus 16 as common. Again, A plus B. This I consider it as a term, this I consider it as a term. What is common between the two? A plus B is common. So I end up with x square minus 16. However, this is not simplified. There is a difference of squares. So that would be x plus 4. Everything should be product. Meaning, do you see? This is a factor, this is a factor, this is a factor. See, you have multiplication in between. This is the intercept form. Got it? Can I go ahead? I'll tell you about the intercept form a little later, but I want you to be able to factor anything given. Can I move on? Akshada, Krishiv, Pratika, did you get it?
Yeah, I got it.
Anam, Advait?
Yeah, I understand.
How about you, Sahana?
I get it.
Good, okay. How about this one, guys? That's a little tricky. 2 by 3 if I take out. 1 second. Yeah, this one is good. How about this? See, honestly, I don't know what are the problems you're doing at school, but I would like you to be able to do all of this. Let's see.
In school, we haven't learned this yet.
Oh, I see. Okay, how about this? How about this? See, here as well, there's no square term and all, but there are 4 terms. That itself tells me that I have to take the GCF. Meaning, looking at an expression and understanding what methodology to follow takes some time. But these are tricks that you can use. There are 4 terms. And looks like there are so many things in common.
Miss Priya, I'm still kind of confused.
You're still kind of confused. I'll see whether anybody is answering. You give me a few minutes, bro. Oh, Ashita, that's right. That's right. It's a tad bit tricky, guys, very frankly. Can I write down? Shall I solve or you are solving? You have to let me know, please.
I don't really understand this one.
No problem. It's a little hard. I told you. I'll do. Pratika, you're almost there, but you missed on something, Pratika. See, guys. Okay, let me do this one. 2 by 3 BC minus. See, the concepts are exactly the same. Okay, this is a term. This is a term. Whatever is split by pluses and minuses are terms. Okay, basically, when this is a term, right, in the term 2 by 3 BC, right, what is this 2 by 3 BC? It's like 2 times 3 times 4. So these are factors of that big number. Factors of some big number. Now, what is common between these two? Who can tell me what's common between these two?
B.
Anna, you also missed a little bit. 2 by 3b is common. When you take that out, c minus 7. See, 2 by 3, if you take it out, c minus 7 plus c minus 7. So now this is a term, this is a term. C minus 7 is common. What are you left with? In this term, you have 2 by 3b. In the next term, what is left with? C minus 7 times what is C minus 7? You should not miss this plus 1. Annam and Pratika, did I help you understand that what you missed?
Yeah, I get it.
So this can be written as C minus 7 times 2 by 3b minus 1. Product of factors. Can we move on? Okay.
Why is it -1?
Oh, sorry. By mistake, I wrote down.
Okay.
Yeah. Can I move on? I want to give you more. Let's see. Yeah, this one is a good one. How about this? We'll solve one or two more in this. I think this is required. Let's see. See, again, when you come in algebra 2, you'll all forget this and we'll review that. Instead of that, please have it in your memory. How about this? How to factorize this? Factorize means expressing it as product of factors. Akshada, did you get ma for the previous problem?
Yeah.
Okay. How about this? Think about what you can take common. Advik, that seems correct. Okay, that's fast, guys. For me, wait, I'm not able to see the answers. I will check one by one, please. Plus n plus 2, correct. Dhruv, correct. Advik, correct. Krishiv, correct. Subi, correct. Annam, correct. Ashita, correct. Pratika, correct. Akshada, can I get your answer? Sahana, can I get it? Akshada. Akshada, can you take 3 as well, common Akshada? On the second side, second term, right? Can you take 3 as well, common? Sahana. What, guys? No. Amni, that's right, ma. Sahana, how did you take that? See, the way you've taken common is correct, but you're not a Sahana. See here, Sahana. If I take n as common, n times what is n square, Sahana? N times what is n square?
N.
N. And then you have a plus here. Copy this plus. N times what is 2n?
2n.
2.
Or 2.
Because n times 2 is 2n. You got it?
Mm-hmm.
And then here, what is common? Plus, copy the plus. Yeah,
3m.
that's correct, whatever you have taken, 3m. 3m times what is 3mn?
3n or n.
3m is taken out, n remains, correct. Plus, now in this, I have taken out 3m. 6m can be written as 3 times 2 times m. In that, I have taken out 3 and m. What remains?
2.
2. Between these two terms, n plus 2 is common, right? What remains? N plus 3m.
Okay.
So that, did you get it, ma? Akshata, you didn't take that n plus 2 as common, right, Akshata? Still. Did you get it, ma?
Yeah.
Good. Krishiv, did you understand? Krishiv?
Yeah, I understood.
Okay, good. How about this? This one is coming to confuse you. Okay, how about this? Whatever be the quadratic equation given, you should be able to solve. Put it into intercept form. Last week, we found the roundabout way to find out x-intercept, right? This week, I want you to give the easy way to find out the x-intercept. Can I do, or you want to do? Please let me know as well.
Miss Priya, I meant for the first one, I meant whole squared and not z squared.
Okay, okay. Are you getting something like that?
I can resend my answer if you
I'm confused. Wait, I want to check what is in here. Why? Uh, okay. Okay, Pratika, the difference of square should again be separated out, right? Okay, Pratika. Avni, the difference of square should again be separated out, right? Ashrita, same thing. The difference of square, there is, oh, Ashrita, you got it, I think, but no. Why is the 2 there, Pratika? Yeah, you got it, Ashrita.
Okay.
Akshara, again, the difference of square should be split, right? Sahana, same thing. The difference of square can again be written as product of factors, right? Meaning you're all getting it, but you missed the last step.
Priyanti, can you show me how to factor this?
I will. Krishiv, why are you writing 2 power, Krishiv? That seems incorrect to me.
Yeah, is my answer correct?
Dhruv, for you as well, the same problem. Difference of square can be written as a product of factors. Right?
Oh, yeah.
No problem. Yeah, no problem. See, only learning. That's why I gave you this. So here, guys, why you took it out as common? Most of you got it now. Why you took it out as common? You have z square minus y square, right? And after that, you copied this plus, took out z as common, you got z square minus y square. Now, in this, you took z square minus y square as common. You took z square minus y square as common. You ended up with, and you're telling this is the answer. No, right? You can still split this. This is difference of squares. Z plus y, z minus y. Then you have z, y plus z. Now, when you think about it, these both are the same. So you can write it out as y plus z the whole square, z minus y. Any questions? Sahana, did you understand?
Yes, I just missed like the last step.
Yeah. No problem. See, you guys, all of you got it. Coming to this itself is a big achievement for me. But at the same time, this is difference of squares. So you should know what, don't say, hey, what is this difference of squares? We already discussed this difference of squares. And perfect trinomials are, this is a perfect trinomial. Perfect square trinomial. That means this can be written as this. Perfect square trinomial. So this is a perfect square trinomial. This is difference of squares. These are sophisticated terms that we start using in algebra and quadratics. So let's go ahead with, I think that's, okay. How about this 2x square minus 8? How do you do this 2x square minus 8? That's a good one. Rishiv, there is, your factoring is correct, but there is a difference of square, right, Krishiv? You can express that still as a product of factors, that x square minus 4 is a difference of square, right?
Yeah.
Yeah, Avni, that's not right. Avni, here the problem is 8 is not a square term. 2x square is not a square term.
Yeah, I figured I saw my mistake afterwards.
Yeah, can you get the correct one for me? I'll wait, guys. I'm not in. Yeah, Krishiv, I think you got it. Pratika, good job. Advik, good job. Guys, if you are not getting it, please tell it out and stop me. Let's not go.
I don't get it.
I'll
I don't
help
get
you.
how to do this one.
No problem. I'll go ahead. Avni, can you send the right one, ma? Krishiv, I think he got it. Avni, Dhruv got it. Akshada, can I get your answer? Akshada? Yeah, so here, see guys, this is not a square term at all. It looks like a difference of square, but these are not square terms. So you take 2 outside of this, that gets you difference of squares. See, this is difference of squares. This can be written as x plus 2, x minus 2. Any questions here? Advait, did you get it?
Yeah.
Okay. Now let's go ahead with this one. How about this? Putting it all together. How about this? X square plus 4x minus 12. This is different. I'm going to do it. X square plus 4x minus 12. Hey guys, this one is very different. Okay. How do we do this? I take this in the format ax square plus bx plus c. I
Is
take
this
this.
when you factor the trinomials?
Yeah, this is factoring of trinomial. So if I take it in this format, right, as soon as I look at it, right, I will try to find out the factors of this that sum up to this. I will write the factors of minus 12. What are they? Factors of minus 12 are, first let me start with minus 1 and 12, or it can be 12 and minus 1. The next one is 2 times. 1 to 12 I have to go through. 2 and 6, or minus 6 and 2. And then I'll go with 2 to 6 I need to go through. I need to go through all numbers between 2 to 6. Then 3, 4 is there. Minus 3, 4 or minus 4, 3. In this, which of these sum up to 4? In this, which of these sum up to a plus 4? In this, which of these sum up to a plus 4?
6, -2.
Yeah, this one. You know, now I go ahead and split this 4x as plus 6x minus 2x and write down. Okay, now once I do this, it's very easy. I take x as common, minus 2 as common. Now I take x plus 6 common. It gives me x minus 2. Any questions? Any questions?
No.
How did you get x minus 2 from minus 2 parentheses x plus 6?
Between these two, minus 2 was common. I took it out. So x remained and a plus 6 remained. In this, plus 6 remained.
Oh,
Now,
and then, oh, I got it. Never mind.
got it? So this one is a little different. How do you, as soon as you see, how do you know? There is one way. This is not a, this is a square term, but this is not a square term. Do you see it? So I will always try, hey, is there any factors of this that sum up to this? Can I move on?
Yes.
Okay. I'm not going to move on. Since I'm going to do more of this, let me see. I want an easier one. What is this? Everything is hard in this. N square plus 3n minus 10. N square minus 3n plus 10. Can we do this? You tell, one of you tell me, what are the factors of this that sum up to minus 3? What are the factors of 10 that sum up to a minus 3? Anybody can say.
5, -2.
5.
Oh, no,
Negative
-2, 5.
-5.
Yeah, 2, -5.
Negative 5, positive 2. Am I making sense? Yes, that does make
But they would multiply to -10, not +10.
yeah. So, okay. So I think I gave the question incorrectly. 1 minute, guys. Let me take it as a minus 10. Does that make sense?
Yes.
I gave the question incorrectly. So now negative 5 positive 2 sums up to minus 3, and when I multiply these two, yes, it goes to 10 times n square, meaning a and c. See, the product should be a and c. The sum should be the middle term. Okay. Now I rewrite this minus 10 and n squared. So between these two, I take n as common. Between these two, I take 2 as common. Again, I take n minus 5, n plus 2 remains. Any questions, guys? Any questions? So the intercept form general format is a times x minus a, x minus b. This is the intercept form for quadratic equation. But what is the significance of it? We'll discuss intercept form.
Can we also do this same thing by using the box method? And like doing
Yes,
this
ma'am. You
in the
can use
box.
the box method. Whatever method you follow, I'm fine. Okay, this is the old school method of doing it. Okay, if your teacher has taught the box method, you can do. Some of them do it as an X method. Whatever method you follow, I'm fine. As long as you're able to find, I'm fine.
In our school, we did the X and the box.
Oh, okay. I'm fine. I'll tell you, this is the very old school method of following. See, write out the factors of 10, write out the factors of minus 10 that sums up to minus 3 is the very old school method. Can I go ahead?
Yes.
Okay. Now, the thing is, what is this intercept form? Let's discuss this intercept form. Okay. Any quadrat, I don't want, okay. This class is 1.5 hours. So sweet of you, the way you have asked. Yeah, is it okay, Advait?
Yeah, I just wanted to know.
Yeah, just this class. Okay, I really want to go ahead and finish all of this before you go on the break. Okay, because we missed the class, right? And I feel guilty not covering it as well. Can I move on? If it is a problem, I'll record it for you as well. Okay, but we'll go for 1.5 hours. Can I go
It's
ahead?
not a problem. I just wanted to know.
Sure. Nice of you. Now let's go ahead. Let's go ahead and try intercept form. I want to discuss this intercept form. Okay. Any function, right? I write it like this. Okay. All the while I was only giving expressions for you. So let's consider this. Okay, this is a quadratic function. How do you write it in intercept form? You know, right? Meaning this expression, if I give, how to write it in intercept form? This one. What is the intercept form of this?
It's x plus 2, x minus 2, x plus 2 squared.
Yeah, x plus 2, x plus 2. So f of x meaning a function, this is a quadratic function. A quadratic function is given by x plus 2 times x plus 2. What is the significance of this intercept form? Let's see. What is this intercept form means? You know, all the while we were plotting linear functions. You used to tell, hey, 3x plus 2, you know how to plot this line on a number line. But now we want to plot this quadratic function in a graph. The intercept form is a very easy way of doing it. Here, the thing is, suppose if I put f of x is my y value, right? Substitute 0 for my y value. If I substitute 0 for my y value, either this factor is 0 or this factor is 0. See, if you have the product of two numbers as 0, right? The product of two numbers a times b is 0. Either a has to be 0 or b has to be 0. If neither is 0, you can't get a 0. So that is called the zero product rule, zero product property. Okay, using that zero product property, I can either make this factor 0. I can make x plus 2 equal to 0. Or I can make again x plus 2 equal to 0. In both the cases, I get x equal to minus 2. So I get x equal to minus 2. From the what am I doing by making y equal to 0? Remember, in our linear equations, if I put y equal to 0, I will get the x-intercept. If you put x equal to 0, you will get the y-intercept. Remember that the same logic applies here. Now we put y equal to 0. So we are finding the x-intercepts. X equal to minus 0 is the place where your quadratic graph is going to cut the x-axis. Here, both values, meaning there should be two places where a quadratic graph cuts the x-axis. There was always one point where the line cut the x-axis because the highest power of x was 1. Here the highest power of x is 2. So there has to be two places in the graph, in the coordinate plane, where the graph cuts the x-axis. However, both the points are the same here. As a result, it takes a U-turn. It doesn't cross from positive to negative or negative to positive. Instead, just because this is called a repeated route. Repeated route, meaning any x-intercept, right, has multiple names. Let's find out the names. X-intercept can be called as a root, or it can be called as a zero of the equation. Zero of the equation, or it can be a root of the equation. Now, if both the roots are the same, meaning basically any quadratic graph will be like this. So there will always be 2 points where it cuts the x-axis. But in this case, it's the same point. So it takes up a U-turn and goes back. That's called a repeated route. Now, from the intercept form, it's very easy to decipher what is the intercept, and drawing the graph becomes very easy. Let's consider the same that we did earlier. How about 2x squared? How about this? Can we try this one? What is the factored form? I'm going to write it as an equation now. See guys, all the while we were working on factorizing an expression given. Okay, now I made it into a quadratic equation and I want to graph it. The equal to sign comes only for equations. Only when equations come, you can put it into a graph. You get it? Expressions just helped you factorize. Now we are putting it into a graph.
Wouldn't it be 2 times x squared plus 8x plus 8?
Oh, did I make a mistake there? Let me check.
No, that's what I got too.
What is it, ma?
2 and then in parentheses x squared plus 8x plus 8.
Oh, 1 minute, ma. I feel like I made a mistake then. Hold on, please. Is it 4x squared? Does it make sense? Wait. Let me see. I gave it out of my brain. Maybe I'm wrong. I'm checking. Yeah, this one is correct. 4x squared plus 16x plus 16. I'm sorry. So how do you factorize this? How do you graph it? I want you to do the intercept form and graph it. I'm not following the book. Okay, I've come out of the book. Okay. But these are all the things that I want you to know. So I just... Can I go ahead and try? Or you want to try? Tell me, what did you get?
I got the x-intercept to be x equal to -2.
Emma, please tell me the factored form.
Oh,
Oh, yeah, I'll do it on the board. Looks like somebody wants to do it on the board, Dhruv. Go ahead and tell. Factored form.
oh.
Go, tell me.
Oh, so it's 4 times x plus 2 times x plus 2.
Really? That doesn't seem right.
I got 4 times x squared plus 4x plus 4.
Yeah, that's
What is it?
4 times x squared plus 4x plus 4.
Simplify that to x.
Ah, guys, you're all a little confused. Okay, that's good. After that?
Yeah.
After that, what happens?
Wait, isn't it just 4 times x plus 2 times x plus 2?
Yeah, Dhruv, you are right. Dhruv, you're right. But Sahana, you should be able to factorize this into this.
Oh, okay.
Got it? So now again, it's going to be a -2. So let me give you another. So here you can write out the factored form as, see here you can take out 4 as common, and then you have x squared plus 4x plus 4. Here, this is a square term, this is a square term, right? See, look at the trinomial, then decide what you want to do. That would be x plus 2 times x plus 2. So, what are your intercepts? Minus 2 repeated 2 times. So, your graph is going to be like this. How do I know that it is pointing up? Because the leading x, the highest power of x is 2. The leading coefficient, the number that accompanies the leading, the highest power of x is the leading, this is called the leading coefficient. When the leading coefficient is positive, it's going to point up. This is just by practice, okay? When the leading coefficient is negative, then the graph is going to point down. Okay, let's go ahead. So now this is the same graph, but I wanted to graph something different, guys. Okay, let me go ahead and give you one more problem. How about this? Yeah, x square plus 4x minus 12. X square plus 4x minus 12. X square plus 4x minus 12. I'm going to do it myself, okay? So when you look at it, this is not a square term, this is not a square term. So it's not going to be a square. But can I find out the factors of minus 12? Yes. Minus 6. No. Plus 6 and minus 2. First, let me do that. And then copy the minus 12 x squared. Between these two, x plus 6. Between these two, minus 2, x plus 6. Now, in this x plus 6 is common, you have x minus 2. So I put it in factored form. But as I said, right, these are just expressions. Let me make it into an equation. I want to find the y-intercept. Y, this stands for y value. I want to find the x-intercept. Then only I can plot the graph quickly. So I equate this to 0. When I
Isn't
equate
negative 12 the y-intercept?
negative,
Negative 12, like from the equation, because when it's in standard form, like the last one is the y-intercept, right? Like the c value.
not really.
Oh.
1 minute. Why do you think so, Ma?
I thought that the c value, like when it's a
Yeah.
squared plus
See,
bx plus
okay.
c, then the
Okay.
c
Yeah.
value is the y-intercept.
Yeah, there you're putting x equal to 0. So you got the y-intercept. We are solving for x-intercepts, right? You are talking about y-intercepts, right?
I thought you said y-intercept.
Okay. For y-intercept, you will put x equal to 0. We are always discussing the intercept form. This is the intercept form. Intercept form means you're going to find out, you're going to equate your y value to 0. So you will end up finding your x-intercepts. X-intercept is the point where it cuts the x-axis. Y-intercept is the point where the graph cuts your y-axis. If I by mistake said y-axis, it's wrong. Y-intercept, it was incorrect. Shall we move on? So now I can equate this to 0. If I equate this to 0, x was equal to minus 6. 0 product property. Either this is 0 or this is 0. X minus 2 equal to 0, x equal to 2. Now, do you see x equal to 2 is an intercept. Minus 6 is another. Okay. Now, is it upward facing? Yes, it is upward facing. So, it's going to be something like this. Do you get it, guys? But we don't draw such bad graphs. What is the vertex? Vertex finding is very easy. How to find the vertex? X value of the vertex is minus b divided by 2a. So that's a minus 2. So minus 2. Minus 2 is the x value of the vertex. So your vertex will come somewhere here. You see? We don't know the y value. You have to find out the y value. So another thing, you can always find out the vertex by using x value of the vertex is minus b by 2a. Now plug in this minus 2 into our equation. Y will be equal to minus 2 the whole square plus 4 times minus 2 minus 12. That is the y value of the vertex. 4 minus 8 minus 12. 4 minus 20. So that's minus 16. So this is 2 comma minus 16. That is your vertex. So this is how we plot. Any questions? Any questions, guys?
Yeah, I have one question.
Yeah, please go ahead.
So what happens if like the trinomial, like you can't factor it out, like you can't find any factors that can fit the B term?
Good question. You want one example like that? There is one more I have not taught you. Using quadratic formula, I have not taught you. Not factorizable. Wait, let me think. Let me bring up something that's not factorizable. Which one, guys? I don't know which one. Hold on. Okay, yeah, I gave you one, right? Remember? I gave you one. By mistake, I gave you something different, right? -4 or minus something here I gave you. I don't remember. Oh my gosh. -10 and then a -3, yeah.
Do you mean the one where it was like
Yeah, this one, right?
two
It was -3 and +10.
-3 and +10, correct. -3 and +10. Here, this is not factorizable, right, Dhruv? We can take the same example, right, Dhruv?
What did you say?
This one, the one, f of x equal to x squared minus 3x plus 10. Do you see?
Yeah, I think I might know how to solve.
Yeah, see this one, I want to take this up. Since you brought it up, I would like to take this up. This one is not, Sahana, can you tell me again? -3x plus 10, Amma?
Yeah.
Okay. So how to solve this? This is, the first term is a square term, but this is not a square term. Now I cannot find the factors of this. 5 and 2, -5, -2, nothing adds up to -3. What do I do here? This is so hard to factor. I cannot find the value of x at all here. I cannot make it go to the intercept form. What do I do?
You have to convert it to vertex form
You have to convert it to it. How will you convert it?
by
Nice.
finding the vertex.
Finding the vertex. Yeah, but if you find the vertex -b/2a, you're saying?
Yeah.
Have you learned completing squares?
No.
Okay, then you can't do. No, I'm not going to go that route now. Okay, one thing is,
You can find the vertex and use the y-intercept as another point to find the a value of the vertex form, and then you have your vertex.
yeah, but I would like to find, I would like to find the x-intercept. How to find the x-intercept? It's hard, right?
Just use the quadratic formula -3.
Exactly. There's a quadratic formula which you can use directly. However, whatever, you will get the answer for x here. Meaning, you will get the x-intercept using this quadratic formula. This says the value of x, that means the 0 or the root or the x-intercept, is given by considering this as ax square plus bx plus c. I can call this as x equal to -b plus or minus b square minus 4ac by 2a. This should get into your brain just like that, no other go. Okay. Sahana, did your school teach this? Not yet.
So the -4 is a constant.
Where minus you? Yeah, -4 is a constant.
Okay.
So minus b. One thing, guys. One thing. Before I move on to this, right? This term, right? This has a very special meaning to a quadratic equation. We will discuss that. That particular term, square root b square minus 4ac is there, right? I would.
Is that the discriminant to see how many solutions the?
Yes. So this one, b square minus 4ac, is very special. We will learn about it a little later. Okay. This thing is called discriminant. Okay. Meaning, whenever I ask for the discriminant of a quadratic equation, you will evaluate b square minus 4ac and tell me the answer. Okay. But a quadratic formula, you will find out x. If you're not able to factorize in any method, this method is the one-stop solution. Okay, minus b. Let me do it that way. What is this minus b? There is a minus b. So please copy the minus. What is b? The minus 3. See, there is already a minus. I'll copy the minus 3. Plus or minus means plus can be there, minus can be there. Because there are 2 points, right? X-intercept. B square is 9, minus 4, A is 1, B is 10. Divide by 2 times A is 1. Now the thing about this is, see here what is happening. Plus 3, plus or minus. You see 9 minus 40, that is a minus 31. Can there be a square root of a negative number? Can there be a square root of a negative number?
No.
There can never be a square root of a negative number. If you square root, whatever is inside should be positive. If you get the square root of a negative number, this is not a real number at all. So the entire x value does not belong to the real number system. You get it? Meaning when you get the square root of a negative number, your x value is not going to be real. Meaning this quadratic equation, when you graph it, is not going to touch the x-axis at all. So this can be like this can be like this, or this can be like this can be like this. That means it's not going to touch the x-axis because the x-intercept is not a real number. I'm going to show this to you. X square minus 3x plus 10. Can I erase this? Let's go ahead and see. I'm going to go to this. Can I go there? Stop share.
Yeah.
X square minus 3x plus 10. Let's see what is in store for us. Desmos. I want you to see what I'm doing as well. Hold on. Where is Chrome? Where is Chrome?
We didn't learn this yet in school. No.
This is what I do. Graphing calculator. I'll type f of x will be equal to x power 2 minus, what to say, x square minus 3x plus 10, Nama.
Yeah.
Okay. See, I told you, this graph doesn't touch the x-axis at all. Meaning, if it touches the x-axis, do you see? So here, I found out, I told you something about discriminant. Discriminant is b square minus 4ac. The x values were minus b plus or minus square root of the discriminant by 2a. Okay, now when I evaluated the discriminant, what was the discriminant? B square was 9 minus 4 times a times c. Here it was a negative value. When your discriminant is a negative value, okay, that means your x value is not real. That x-intercept or the 0 is not real. Okay, not real means the graph is never going to touch the x-axis. Okay, that's what you can conclude. So if your discriminant is negative, it is very clear that the graph is not going to touch the x-axis. Your x-intercepts are not real. You are not going to have real roots. Okay, so the roots of this equation are going to be imaginary. This imaginary numbers is out of scope of algebra 1. Okay, so you are just going to conclude that the graph is not going to touch the x-axis. Any questions?
No.
Okay. Now, the discriminant has got very special value. Let's say x square plus 4x plus 4. How is the discriminant? Let's find out the discriminant here. We did not discuss much about the discriminant. B square minus 4ac, right? See, this one you already factored it. We already did this. I'm going to change the equation here. Let's change the equation and try x squared plus 4x, right? See, please meddle with these Desmos graph or calculators at home. Otherwise, these things you will never understand how what works. B square minus 4ac is 16 minus 4 times 1 times 4. 16 minus 16, d equal to 0. Did you see it, guys? So when you have discriminant equal to 0, did you see it was when you have discriminant equal to 0, you have real repeated root. Real root means the graph touches the x-axis, but you have a real repeated root. Okay, the discriminant is very powerful. It can tell you how is the graph going to be. So discriminant is a very special thing in quadratics. Discriminant. Yeah, it's called the discriminant. D is called the discriminant. So we covered D equal to 0. We covered D less than 0. Correct? Okay. Can I go ahead? So we covered only 2 things. We want to cover the others. Wait.
Auntie, when do we learn about imaginary numbers?
Recalc. Algebra 2, Lemma.
Okay.
Algebra 2 you learn. Okay. 1 second, guys. I want to cover the other 2 as well. Since we took up discriminant, I want to finish that. Yep. 1 second. Let me come up with this. So we studied about, okay, how about this? Okay, how about this? I really want to show the nature of the roots first and then we'll see. Okay. That's not what I want. Yeah, this is what I want you to see. Not this one. 1 second, guys. This is what I want you to see. Okay. See, the discriminant, as I said, has got very special significance, right? So let's talk about the discriminants in detail. What can be the different values of the discriminant? You see, since we talked about discriminant, I want to discuss that in detail, okay? The discriminant of a quadratic equation can be equal to 0. We covered this. Then what happened when it is equal to 0? The root was real number, meaning it touched the x-axis only one. It was a repeated root. This happened in x square plus 4x plus 4. Remember, this was the quadratic function. We put it out as x plus 2 the whole square. So when you look at it, the intercept was minus 2 minus 2. So it is real and equal. When it was less than 0, you did have not real roots, meaning in this case, the graph touched the x-axis only once because it was a repeated root. In this case, the graph did not even touch the x-axis. This we solved it for f of x equal to x square minus 3x plus 10. Right? Now the last 2 we'll do. The other case that we did not cover was discriminant can be greater than 0. Okay, if it is greater than 0, it can be 2, 3, 4, 5, 6, 7. It can be anything. So if it is a perfect square and not a perfect square are 2 things we need to consider. Positive numbers can be anything. It can be a square number or it need not be a square number. If it is a square number, then your roots are real, rational, and unequal. If it is not a perfect square, then your roots are real, irrational, and unequal. What are these? It's so confusing, right? We will solve examples of each. Let me solve each of this, okay? You know what? Okay, let's go ahead and solve each of this. So how about this? Is greater than 0. Okay, how about this? How about, that's hard, guys. Give me a minute. How about this? We'll solve this one. Let's solve this one. I don't know how is it going to be. Let's see this one. Can we try this one? How is the discriminant going to be? The discriminant is b square minus 4ac. I'm given this quadratic equation. So b square is 100 minus 4 times a times c. So this is a 100 minus 100, 0. So what type of roots I'll have? What everything is in here. You can look at the board and say the answer. If the discriminant is 0, what will be, how will my x values be?
Real and equal.
Real and equal means in the graph, what happens? It's either going to be like this. Once only it will touch, right? Going to be like this, or it can be like this. So here I do see the leading coefficient is a positive 1. So it has to be this or this. Make sense? Here, can I factorize it? 5 and 5. X square minus 5x minus 5x plus 25. X will be x minus 5 and then minus 5 x minus 5. So this is x minus 5 the whole square. It's a real repeated root. Do you get it, guys?
Yes.
So the determinant tells a lot about, it helps you a lot. Make use of the discriminant. Determinant is used elsewhere. This is called the discriminant. Okay. So now if it is equal to 0, you know well. If it is less than 0, the graph won't even touch the x-axis. I already showed you. Okay. Now if it is a positive number, it can either end up in a perfect square or it need not be a perfect square, which we have not covered. Let's try that one. Give me a minute. Sometimes they'll ask you for the nature of the root based on the discriminant. How about, I want some nice examples, guys. Hold on. I don't have it. Hold on. It's a good one. Let's see this one. I don't know. X square minus 4x plus 3. X square minus 4x plus 3. X square minus 4x plus 3. This is what I'm going to solve and show you. Krishiv, are you following?
Yes.
This is my quadratic equation. Means if I ask you, hey, how are the x values? They won't ask you how are the x values going to be. They'll ask you in a sophisticated way. Hey, what do you think about the roots of the equation? How is it going to be? Roots means what are they asking? What are the possible x values? So I'll find out the discriminant. B square minus 4ac. So that is 16 minus 4 times 3 times 1. 16 minus 12. That's a positive number. Do you see? If it's a positive number, it can either be a perfect square or not a perfect square. This is a perfect square. So my x values I expect to be real, rational, and unequal. Real, rational, and unequal means it can be expressed as a fraction, or it can be a fraction. Basically, it can be a fraction. It has to be real. Okay, it has to touch the x-axis. So let's go ahead and try what is it. Let's see. X square minus 4x plus 3, right? How do you factorize this? X square minus 3x minus x plus 3. I take x. Pratika, are you following, Pratika?
Yeah.
X minus 1, x minus 3. See, x can be equal to 1 if I equate it to 0, because then only I'll find out if I equating it to 0 means my y value is 0 only at the x-intercept where the graph cuts the x-axis. My y value is 0, so I'm equating to 0. Then I'm, by the zero product property, I'm equating each one to 0, getting the values as x equal to 1, x equal to 3. So what will be my graph? 1, 2, 3. 1 and 3 are my x-intercepts, right? The graph is going to be like this. Any questions? Why it is facing upward? My leading coefficient is a positive value. So this is how I plot it. Now, for a perfect square, see, real, rational, unequal means the x values can be positive, fractions, or whole numbers. Rational means you know what are rational numbers, right? So this is an example where the discriminant value was a perfect square. It obeyed this. Any questions still here? Sahana, are you following?
Yes.
Okay. How about this? X square minus 7x minus 4. I'm going to take up the next one. X square minus 7x minus 4. X square minus 7x minus 4. I'm going to take up the last one. X square minus 7x minus 4. Okay, with this we'll complete, guys. Now in this case, what do you think? What is the d value? B square minus 4ac, right? How do you find it? B square is 49 minus 4. So 49 plus 16, 65. Do you see it's greater than 0, but it is not a perfect square? Can we try finding the roots? X square minus 7x minus 4 equal to f of x. I have no way to factorize this, okay? I'll go with the quadratic formula. X will be minus b. Minus b means minus b. Minus outside and then the b value. Plus or minus square root of the discriminant. I already found the discriminant. Divided by 2. 2a means 2 times 1. So this becomes 7 plus or minus square root of 65 by 2. That means what? X value can be 7 plus square root of 65 by 2, or x value can be 7 minus square root of 65 by 2. Any questions? Here, see this one, because of the square root of 2, square root of 3, square root of 5, square root of 7, square root of 11, all these are irrational numbers, right? Because of the square root, the x values are irrational. They are real though, real number, irrational, and they are unequal. They are not the same. So now, what can be the square root of 65? It can range between 8. Approximately square root of 65 is 8 point something. So it can be 7 plus 8 is 15 point something, or it can be 7 minus 8 is 0.1 something. So when I draw the graph, x value can be 0.1 by 2, 15 point something by 2. So x value can be 7 point something and it can be 0.15. So these two are the x values. My graph will go like this. But the problem here is these are irrational numbers. These are not nice whole numbers like what was in here. That is why when the discriminant is greater than 0, you have real, irrational, and unequal roots. Any questions? This was a little difficult, right? But the significance of discriminants are understood. Any questions till now? Meaning we just understood what are discriminants, the significance of discriminant. It can be equal to 0, less than 0, greater than 0. And how do you find your x values using the quadratic formula? Any questions? No. Okay. After the break, right, we'll go ahead and do word problems, guys. Okay, that will be very useful. Okay, whether you do it at school or not, we'll do word. We will again grind the same thing, meaning we'll do more of quadratic formula after the break, and then we'll go ahead and do word problems. Okay, a lot of application problems we can do in quadratics. Okay. If you have any questions, you stay. Otherwise, we'll stop here and I'll give you an assignment on factoring completely and then using discriminants, how to find out the roots. What is the nature of the roots? And graphing. If you have any questions, you stay. Otherwise, we'll log off. And thanks. You're all so awesome staying 1.5 hours.
Bye, Miss Priya.
Yeah, ma.
Miss Priya.
Bye.
Bye.
Bye, guys. Have a nice break, guys.
Bye.
Bye, guys. You're very tired, Subi.
I just want to ask about the homework. So, whenever I do it, I post it on. How do I like submit it?
You know what? Usually, if you submit by the deadline, I see, ma.
Well, like, how do I submit it? Because there's no like submission.
There is a submission, right? Can you share your screen?
I have to like log into the.
Google, yeah. Meaning because your interface is different from mine. Do you want to share screen?
1 second. I just need to log into it.
Yes.
I don't usually have it open because none of my classes are in here.
Okay, no problem. Want to share it?
Yeah, 1 second.